Yesterday, we talked about one of the types of friction. We called it kinetic friction, dynamic friction, or sliding friction. It was the force of friction that acted between two surfaces when an object was moving, or more particularly, sliding along another surface. Today, we're going to talk about static friction. That's the force of friction that keeps an object, or at least attempts to keep an object, from beginning to move in the first place. Right now, this desk is at rest. If I give it a push, it moves, it slides. As it's sliding, kinetic friction tries to stop it. But right now, as I push it a little harder before it begins to move, it's static friction that opposes my force that keeps it from beginning to move. So we're going to define static friction as that type of friction, that force of friction acting on an object that helps prevent the object from beginning to move in the first place. So if an object is at rest, you have to overcome static friction to get it moving, and then it becomes kinetic friction that's acting on it as it's moving. Now, static friction is a little different. Sometimes I call the static friction the stubborn friction, static or stubborn friction. Now, that's not really a name for it, of course. It's not an official name for it, a real name for it, but I call it the stubborn force of friction because static friction, it's that force of friction that says, you push hard, I'm going to push harder. You push harder, I'm going to push harder. I'll push as hard as you push. It's that stubborn force of friction that reacts to what I do. Right now, this desk is at rest. I'm going to push on this desk with a force of 2 newtons. Guess what? Desk doesn't move. That must mean that static friction pushed back with 2 newtons. Now I'm going to push on this desk with a force of 10 newtons. Guess what? Desk didn't move. That means that static friction pushed back with a force of 10 newtons. I'm going to push on this desk with a force of 20 newtons. Guess what? Desk didn't move. That means that static friction was pushing back with 20 newtons. It's a stubborn force of friction. It pushes back however hard it needs to push back. It pushes back to oppose the force that I apply on it. If I push harder, it pushes harder. If I push even harder, it pushes even harder. It's that stubborn force of friction until that force of static friction just says, okay, enough is enough, I give up. There comes a point when static friction says, I'm not going to push anymore. I push with 2, it pushes back with 2. I push with 10, it pushes back with 10. I push with 20, it pushes back with 20. I push with 25, and static friction says, I give up. Go ahead and move. Now it becomes kinetic friction. So static friction varies with how hard I push. Unlike kinetic friction, if the desk is moving, the force of kinetic friction is a constant. It doesn't matter how fast it's moving, how slow it's moving. Once we have an object that's moving, kinetic friction is the same value no matter what. But static friction is stubborn. It pushes harder as I push harder, unless I push harder than the maximum possible value. So let me give you an equation here, okay? This is a little bit weird too. It's going to look similar to the last equation that I gave you, but it is a little bit weird, and I'll explain what I mean by that in just a second. We're going to say FSF, the force of static friction, max. We are never going to calculate the actual force of static friction. We can't do that. We can only calculate the maximum possible value of static friction. That's equal to mu s, that is, times the normal force. So when I say mu k times the normal force, that's not the maximum kinetic. That is the force of kinetic friction. But when I say mu s times the normal force, that's not the force of static friction. That's just the maximum possible value. Remember the example that I gave you with the desk just a minute ago. I pushed with 2. That's not what I get from this equation. That's the actual force of friction that acts on this desk is 2 newtons. I push with 10. That's not what I get from this equation. That's just the actual force of friction that's acting. 20, that's not what I get from the equation. If I push with 24 and it doesn't move, static friction is 24. If I push with 25 and it starts moving, well, that's the force that overcame the force of static friction. So that would be the maximum possible force of static friction. That's what I'd get from this equation, the 25 newtons, the force that was required to get it moving, the maximum force of static friction. So this is what we said just a minute ago. Static friction behaves a little differently than kinetic friction, and it's as strong as it needs to act. When I push with 2, it didn't push with 10 because it didn't need to. I pushed with 2, all it needed to do was push with 2 to keep the object at rest. I pushed with 20, well, it needed to push harder, so it pushed harder. It pushes as hard as it needs to push. And that value is always going to be however hard I push until it begins to move. Well, then I've overcame the force of static friction, it becomes kinetic friction. So static friction behaves differently than kinetic friction in that it acts only as strong as it needs to. The value of static friction will always be equal to whatever force I apply until I reach the maximum value, that 25 newtons in the example that I gave you with the desk, and then it begins to move. Now it's not static friction anymore. Now it's kinetic friction. Now that static force of friction is not always greater than kinetic friction, but the maximum possible static friction in a situation will be greater than kinetic friction. In other words, you can push with a certain force, not start an object moving. That doesn't mean static friction is that great. But if I keep pushing harder and harder and harder, we will find the force that's required to get it moving to overcome static friction is bigger than the force of kinetic friction, the force required to keep it moving. So look at example number 4 here. Example number 4 says a 30 Newton force is required to cause an object, a 10 kilogram object, to begin to move. We want to find the coefficient of blank friction between the object and the floor. This would be static friction. The object is not moving. We have to overcome static friction to get it moving. So this would be the coefficient of static friction as opposed to kinetic friction. Now, what is this 30 newtons? Well, that's an applied force. But that's not the force that's required to keep it moving at a constant speed. It's not moving at a constant speed. It's not remaining at rest. It's starting to move. We're not in a state of equilibrium here. This is not the force of friction that corresponds to the force of static friction. Sorry, the force of kinetic friction. If I push with 5 newtons, think about this. I push with 5 newtons on this. Does it move? Reese? No, 30 newtons is required to get it going, right? If I push with 5 newtons, how much is static friction going to be? 5 newtons, because it acts as hard as it needs to act, right? If I push with 20 newtons, does it move? No. The force of static friction would be 20 newtons, though, right? Because that's how hard I push. It's a stubborn force of friction. It pushes as hard as it needs to push. I push with 29 newtons. Does it move? Ambrose? No? No? So that means static friction would be 29 newtons, right? However hard I push, it's a stubborn force. It pushes as hard as it needs to, right? I push with 30 newtons. It does move. That would be the force required to get it moving, but it would also correspond to the maximum possible force of static friction. Does that make sense, you guys? The force required to keep it moving at a constant speed was the force of kinetic friction. The force required to get it moving is the maximum possible force of static friction. Sometimes static friction was 2 or 10 or 20 or 29. Static friction is not always this value. This is just the maximum possible value. Now I got a mass here of 10 kilograms. and I'm looking for the coefficient of static friction, mu s. So I'm going to say FSF max is equal to mu times the normal force, mu s times the normal force. Let's rearrange this, solve for mu s. I get FSF max divided by Fn. We're going to say 30 newtons divided by 30 times 9.81. .102, and there's no units associated with that. It's just a coefficient of friction. So if 30 newtons is required to get it moving, that doesn't mean that's what static friction always will be. It's only going to be as big as it needs to be. But the coefficient of static friction will always be, because of these two materials, 0.102. That's not a maximum coefficient. The coefficient is the coefficient. But the maximum force is not necessarily what the force will always be. Kinetic friction is easy, right? I calculate it, there it is. But with static friction, I calculate it, it's not what it always is. Make a mistake here?
Would it be mass?
What did I do? Oh, it would be mass times 9.81. You are right. So that's 10 times 9.81. Thank you. Sorry about that. That makes this a wrong answer. What do we end up getting for that one? You saying? 0.30, go 3 digits. Oh, actually, it would be 2 digits, 0.31. That's probably a better value. Actually, it makes more sense, right? 0.1 was possible, but that's pretty low, right? 0.3 is probably more realistic, unless we're talking about ice, right? Thank you for that. So the force required to keep it moving at a constant speed is the force of kinetic friction, because of that equilibrium thing. We're not in equilibrium here. The force required to get it moving is not necessarily the force of static friction. It's the maximum force of static friction. The maximum force of static friction between the desk and the floor is 30 newtons, and I push with 30 newtons. That's what static friction is. But if I push with 12 newtons, static friction isn't 30, it's just 12. It's only as big as it needs to be to keep it from moving. Let's have a look at worksheet number 13 now, questions 1 and 2. So we'll get number 2 for us here. There's a 25 kilogram block initially at rest on the rough horizontal surface. 75 newtons is required to set the block in motion. 60 newtons is required to keep it in motion at a constant speed once it's moving. What are the coefficient of static and dynamic, or static and kinetic friction? We get 2 separate problems here, right? We have 25 kilograms. Let's write that down. That's the easy one. 25 kilograms is the mass. 75 newtons is required to get it moving. What does that correspond to? Yep. Yes, that's not necessarily the actual force of static friction that's acting at any given time. That's just a maximum possible force of static friction. So I'm going to say that is FSF max. 75 newtons is required to get it moving. 75 newtons is required to overcome the maximum force of static friction. The FSF max must be 75. Now, what is the 60 Newton thing? That's a whole other force, right? Yeah. That's the force of kinetic friction. Technically, it's the applied force, but if it's moving at a constant speed, we're in a state of equilibrium. Forces must balance. So the force that I'm pulling with has to be equal and opposite to the force that friction is pulling backwards with. So FKF is 60 newtons. And I want to find the coefficient of static friction and the coefficient of kinetic friction. I don't really care which one you do first. Both of them we're going to do pretty much the same way here anyways. Let's say mu s is FSF max divided by Fm. So let's find that one first. SFS max is 75 newtons divided by Fn is 25 times 9.81. Divided by brackets here, 25 times 9.81 gives me a value of 0.31. 0.31. Now, before we find the coefficient of kinetic friction, do we expect that coefficient of kinetic friction to be bigger or smaller than static friction? Smaller, right? We didn't say that static friction is always bigger than kinetic friction, but the coefficient will always be bigger than kinetic friction. Does that make sense? The maximum static friction will always be bigger than kinetic friction. Not necessarily the actual value of static friction, but the maximum value. So we're going to say mu k is equal to fk divided by fkf, I should say, divided by fm, and we should expect to get a value that's smaller than 0.31 here. Let's see, 60 newtons divided by 25 times 9.81. And that gives me 0.24. Yeah, sure enough. That seems reasonable, right? Coefficient of kinetic friction less than the coefficient of static friction. That's why it's easier to keep an object moving once it's moving than it is to get it moving in the first place. Right? We know this, right, from experience. If you get a heavy object, you push, can't get it moving, can't get it moving. And then once it starts moving, once you overcome that max force of static friction, now it's easier to keep it moving because mu k is less than mu s. The force of kinetic friction is less than the maximum force of static friction. Okay, one more example for you today, and then we'll pack it up for the day, all right? Let's look at example number 6. I'm not sure what number it is in your booklet because the numbering seems to be off a bit, but you'll see it here. Oh, it is number 6 in your booklet. Good. There's a 20-kilogram box at rest on the floor is being pushed to the right. There's a coefficient of static friction between the floor and the box of 0.6 and kinetic friction of 0.4. Those numbers seem reasonable, right? Kinetic friction coefficient less than static. Sure. What's the force of friction between the box and the floor if the box is pushed with a force of 50, 100, 150, 200? Here's the thing. We're not told if it's moving or not. How do we find out if it moves? Any idea here? This is a tough question. How do you find out if it moves? We have to know what type of friction we have in order to know how to calculate it, right? In order to know what to calculate. How do we find out what type of friction we have? I'll tell you what, let's calculate over to the side here. Let's calculate FSF max. Just bear with me on this one for a second. Mu s times the normal force, right, Levi? So we're going to say mu static is 0.60 times, well, the normal force is m times g, 20 times 9.81. Let's calculate that. 0.6 times 20 times 9.81 gives me a value of 117.72. That's not a final answer, so I'm not going to worry about rounding that right now. 117.72 newtons. That is not the force of static friction. That is the maximum possible force of static friction. Static friction is just however hard I push, right? Unless it exceeds the maximum value. Okay, well, I push with 50 newtons here. I'm going to push with 50. Does it move? Maximum is 117, Presley. Maximum is 117. I push with 50. Does it move? You're right. It does not move. Okay, so what type of friction do we have here if it doesn't move? Static or kinetic? Static. Okay, what's the value of static friction? Remember, the maximum value is 117. But what's the actual value? Yeah, 50. The actual value is just Just does what it needs to do, right? It's the stubborn force. It just does what it needs to do. I push with 50, it needs to push with 50. So we're going to say the force of static friction, not FSF max, that's 117. The actual force of static friction would be 50 newtons here. If I push with 100 newtons, does it move? How much do I need to push with to get it moving? How hard do I need to push to get this thing moving in the first place? .72 newtons. I push it with 100 newtons. Does it move, you see? No, it doesn't. So what kind of friction do I have here? Static friction. Okay. What is the value of static friction here? Not 117. That's the maximum possible value. What is the actual value of static friction? 100. Static friction is just however hard it needs to be. Just responds to what I'm doing, right? It's the stubborn force of static friction. I push harder, it pushes harder. Unless I exceed the maximum possible value. I push with 150. Does it move? Yes. Grace, does it move? Yeah, it does. Because I exceeded the maximum possible value. All right. What kind of friction do I have here? Kinetic friction. What's its value? Hold on before you answer that. We don't know what its value is. We have to find it. Force of kinetic friction is mu times the normal force. So mu k is, what is it, 0.40 times the normal force of 20 times 9.81. Let's calculate that one. That gives me a value of 78.48. We'll round that to 2 digits. So static friction in the first one was 50 because that's how hard I pushed. Static friction in the second one was 100 because that's how hard I pushed. Static friction in the third one is 0 because it moved. Now it's kinetic friction. Kinetic friction is 78, not because that's how hard I pushed. It's not a stubborn force. It doesn't care how hard I push as long as it's moving. We just calculate its value based on the equation. Now if I push with 200, does it move? Does it move? Yeah, it does. So what's the force? So it's kinetic friction then, right? What is the force of kinetic friction? 200? No. What's the force of kinetic friction? Right there. 78 newtons. It's not a stubborn force. Right? Kinetic friction, just I calculate its value. As long as it's moving, that's what its value is going to be. Hey, I could add an E to that. 6E. I push with a force of 17,124 newtons. 17,124 newtons. Does it move? Yep. What type of friction is it? Kinetic? Yep. What's the value of kinetic friction? 78 newtons. Doesn't matter how hard I push. Static friction is stubborn. It matters how hard I push. Kinetic friction isn't stubborn. It just is what it is.